Hi, everyone. I'm Mark Lubkowitz. I'm a molecular biology professor at St. Michael's College, and I've been making videos for my molecular genetics students. And I got a couple of emails from students asking me if I would look into the internet rumor that draws a connection between the severity of COVID-19 and ibuprofen. I have to tell you, I was a little bit hesitant to put out this video, and I gave it some thought, and here's why I was hesitant. I am not a healthcare provider, and I do not want to be giving healthcare advice. So if you have questions about whether or not you should take Advil, you should really contact your physician. And please remember, I'm also not a public health advisor too. If you have questions about that, you should look at the WHO, the CDC, or your state and local health departments. With that said, what I can do is I am a scientist, I'm an informed citizen, and anytime I run across an internet rumor, I try to chase it down to see if it's true, especially if it's in my field of interest. So I am going to walk you through what I did to look into this, and maybe that'll be helpful. All right, so I made a little PowerPoint presentation that I want to share with you, and there it is. Dun, dun, dun. And let's start it from the beginning. So anytime that I have a question about anything that's biomedically related, I go to what is the largest database on our planet for biomedical research, and that is NIH's database for publications that's called PubMed. PubMed has over 30 million publications in it, most of them, but not all of them, but most of them are peer-reviewed, and so it's as good a place as any to start. It's actually probably the best place to start. And of course, like all of these, you need some sort of search terms. I just used COVID-19 and ibuprofen. I also tried COVID-19 and NSAID, or non-steroidal anti-inflammatory drugs. Didn't get very many hits with that were useful, so I'm going to show you what I found when I typed in COVID-19 and ibuprofen. So I really only got 2 hits that, as you can see in my list here, which is a very small number, and actually was sort of surprised by that and how much attention this has gotten. And I want to just point out a couple things on this hit list. So the first thing I do when I'm looking at this is I notice that both of these were in the same journal, in a journal called BMJ. This is not a journal that I was familiar with, and because not all journals have equal rigor, shall we say. Some journals are more reputable than others. So the first thing I did was, before I even looked into these papers, was I looked into the journals to see how reputable they were. All right, so what did I find? Let me clear my drawings and get ready for the next slide here. So how reputable is the British Medical Journal, which is what BMJ stands for? So I'd never heard of BMJ, as I just mentioned. So it turns out when I looked into it, it's been around since the 1800s, and it has an impact factor of 27.6. For those of you who are not familiar with impact factors, this is a way that scientists use to try to quantitate how important or how reputable or how impactful, as the name, any given journal is. For comparison, because a number like 27.6 really doesn't tell you anything, because for all you know, the scale goes 0 to infinity. So for a comparison, let's look at Science, Nature, and JAMA. So Science and Nature, which are sort of the gold standards for basic research, have impact factors of 31 and 36 respectively. And JAMA, which is one of the most reputable journals, which stands for the Journal of the American Medical Association, has an impact factor of 30. So BMJ with an impact factor of 27, it's a pretty good journal. So what I did next was I looked at those 2 articles, and it turns out that they're not really articles. They are, let me get my little drawing tool here. First of all, notice that when I clicked on it, it's actually under the news section. And so what does this mean if it's under the news section? What it really means is that it's not peer-reviewed. Okay, so this is not a peer-reviewed study that appeared in this journal. It is, in fact, just a news article. When I read the news article, what it was about was there was a physician in southern France that made an observation. And I highlighted everything that I think is really relevant that I clipped from the article and read. So you have an infectious disease doctor in Southwest France. Okay, so she made an observation. She had 4 cases of young patients with COVID-19. And here's the important piece: with no underlying health problems, who went on to develop serious symptoms after using non-steroidal anti-inflammatory drugs in the early stage of their symptoms. They were on ibuprofen. So this is an observation. Is this a peer-reviewed study? Absolutely not. Is 4 a coincidence? Potentially. Is 4 causative? No way to tell with that small of a sample size. So at this point, this is just an observation. As you are probably all aware, the way that good science works is somebody makes an observation, and then that is the basis of a study, a looking into it further. Where things went sort of awry is the French health minister, Olivier Véran, tweeted out the following: taking anti-inflammatory drugs, ibuprofen, cortisone, could be an aggravating factor for the infection. If you have a fever, take paracetamol, which is Tylenol. And from there, the internet rumor was born. All right, let me clear my writing here before we get to the next image. So a week later, the European Medical Association published another news piece. This is once again an opinion piece in the same journal. And once again, I highlighted the important pieces in red, where they make the argument that there's no scientific evidence establishing a link between ibuprofen and worsening COVID-19. And that is true because no study has been done. Someone made an observation in their clinic, which is appropriate. They reported it, which is appropriate. And my guess is that now it is going to be the basis of several studies, which is once again appropriate. And so you'll notice that they have here, they're monitoring the situation closely, which is code for saying they're looking into it. And then down at the end here in the red, that bottom paragraph, healthcare professionals should consider all available treatment options, including Tylenol and ibuprofen. So it's sort of splitting the fence there, not really making a call, saying we don't know enough to make a call, which is scientifically accurate. All right. I didn't find this interesting enough on PubMed because of the search terms that I was using, but as I started to do what I call the literature trace, which is when I was looking at the articles that were cited in those news pieces that I just showed you, I ran across this one. So this is a rebuttal that was published in Science by an individual named Dr. Garrett Fitzgerald. I looked online into his CV. He is the chair of the Institute for Translational Medicine at Penn. Penn is one of the best medical schools in the US, certainly one of the best ones in the world, which is my guess why he is writing opinion pieces in Science. And in this opinion piece, he really goes out to ask the question, is there a plausible mechanism? And here's why. Because you have to remember that in science, there is no magic, right? If it happens, there has to have been a mechanism. If there is no mechanism, then it wasn't plausible. So is there a plausible mechanism? Once again, not saying that this is the mechanism, but is it plausible given what we know? All right, so what do we know? Okay, so there are a group of enzymes called the COX enzymes. COX-2 enzyme is going to be the most important one for our story here. Keep in mind that there's more than one and that the story is so much more complicated than I'm going to make it sound in the next 30 seconds. So COX-2 enzymes, what do? They make a group of signal molecules that are called prostaglandins. Prostaglandins are the mediators of fever and inflammation. Okay, so the reason you get a fever and you get an inflammation is because prostaglandins were produced. Turns out that ibuprofen is the negative regulator or inhibits COX-2 enzymes. And so the way these work mechanistically is when you take ibuprofen is you lower the activity of COX-2 enzymes, that lowers the production of prostaglandins, and of course, ideally that lowers your fever and that also lowers your inflammation. Now, even though the following work that I'm about to present in this, that came out of Dr. Fitzgerald's paper, he didn't produce himself, he mentions a 2006 paper that linked, and this actually really is fascinating, that linked SARS to the COX-2 enzyme. And specifically what this group showed in 2006 was that SARS has a protein that will actually lead to the increased transcription of COX-2, leading to more of the enzyme. So what does that mean? Does that mean, so first of all, remember that SARS is a coronavirus. It's not COVID-19, but it is in the same family. And so what he's saying is that there is one coronavirus that we know is in the same neighborhood as ibuprofen during its pathogenicity. Does that mean, is that a mechanism? No, that is not a mechanism. Does it suggest a mechanism? Potentially. And I love the quote that he ends his paper with that I'm going to share with you here because I think he says it much better than I'll ever be able to say it. So if we see a clinical signal, we can rationalize it, but therein lies the challenge. Many clinical antidotes remain stalled in biological plausibility. So is it a plausible mechanism? Yes. Is it proven? Absolutely nowhere close to being proven. All right, for those of you that are in my class, or for those of you that are molecular biologists that are following this, if you want to go and look at that 2006 paper, here is the reference. And as I was preparing to do this morning, I ran across yet another editorial that just came out in BMJ. I haven't had a chance to read it, so I'm not going to comment on it, but I just thought I'd share that the story's not over yet. Okay, so what does this mean? What is the take-home message? The take-home message is that a physician made an observation on 4 patients. She appropriately reported it. A French minister then tweeted it. Has there been a study done? Sounds like there's some in progress. And one of my students asked me, how hard could it be to do a study like this? Well, consider this. We know already, we being scientists and physicians and really the public now, that there's an age effect to COVID-19, there's a sex effect to COVID-19, and there's a comorbidity effect to COVID-19. So to really try to tease out ibuprofen in there, you would need to be able to separate and control for every one of those variables. I'm not saying it can't be done, it clearly can be done. I'm just saying it's not a trivial analysis. So what's the take-home message? What am I going to do? I know that's what everybody wants to know. I know my students are saying that. What are you going to do? Well, I'm going to do I'm going to do exactly what I said at the beginning. I'm not a healthcare provider. I'm going to call Richmond Family Practice if I get COVID-19. I'm going to talk to my physician, Dr. Dan, and get a professional's opinion because I'm going to assume he knows best. Okay, that's what I did. That's what I discovered today in my my internet search on trying to chase down an internet rumor. I hope it was helpful. Remember, if you need healthcare advice, go to your healthcare provider. I'm Mark Lubquist from St. Michael's College, trying to rise from the ashes like the phoenix. And remember, let crisis bring out the best in you. Cheers.